Thank you very much. And I'd like to say it is so great to be back in person to be doing these. What I'd like to talk to you about today is the new set of Bluetooth specifications that have, most of them come out, a few to go. It's called Bluetooth Low Energy Audio. It's a complete rewrite of all of the Bluetooth specifications. It's the biggest single specification release Bluetooth's ever done. There's about 1,300 pages and 25 specs amongst them. So I'm going to try and cover those in the next 9 minutes and hopefully get you excited about them. Why we do them? When we first started writing Bluetooth, we basically had mobile phones, some rather silly headsets, and that was about it. Since then, the world of audio and wireless audio has taken off. We have all sorts of things we connect to, all the computing things we have, but increasingly we're seeing voice embedded in more and more products, from voice assistants to microwave ovens. You can even get washing machines that talk to you these days. And the specs we had didn't really work very well with that. We spent time saying, can we start redoing these? Can we extend them? And the feeling was, no, it actually needs a clean sheet of paper. Now we know what we're doing. A lot of it came down to the things that we can't do. The current ones we have are very constrained on the ways you connect. It's very much one-to-one device. But we want things like lower power, we want more flexibility, we want different topologies. We want better support for remote control so that you can distribute your control around, and that's really important if you're in a wearable space. Wearables don't deal very well with Bluetooth today. We want to make it a lot easier. And almost all of this work actually started off being driven by the hearing aid industry, which I think surprises a lot of people. They understand low power because if you have a hearing aid, it needs to run for 2 or 3 days, and it runs on a tiny primary battery. It's far more power efficient than any earbud you can buy. But also things like the telecoil that lets people with hearing loss pick up broadcast sound wherever they are is something we couldn't do in Bluetooth, and we wanted to put that in. It was interesting. This started up as a small group of hearing aid companies and a few phone companies. And within a year, we had about 100 consumer electronics companies coming along and saying, we want to hijack this and make it even better and do all the things we want to do. So it's all come together. The most important one is we have a new codec, which is much, much more efficient than the previous ones. And I'll talk a bit more about that. So it started almost 8 years ago. A year after that, a very iconic product came out. These were the Dash earbuds from Bragi, German company. And they basically were the first ones to come out and say, let's do stereo in independent devices. Now, that's interesting because Bluetooth doesn't support that. It still doesn't support it as a standard. All of the earbuds you see today have proprietary solutions to make that work. So Dash came out. It was the most funded startup on Kickstarter at the time. But it struggled as it's really difficult putting all that tech into one device. 3 years later, Apple came along, and the rest is basically history. Last year, around 500 million earbuds were made. It's the fastest growing consumer product in history, almost by an order of magnitude. It's amazing how fast that's taken off. And it's one of the reasons it's taken us so long to write the specs, that as everybody has seen this happening, we've had more and more spec creep coming in. But the things we want to do, we want to be able to broadcast separately to left and right earbuds. So if you have a hearing aid in one ear and an AirPod in the other ear, they will work with each other. They'll just work out of the box. We want it to be low latency. So if you're listening to your TV and you hear the ambient sound as well, there's not a delay. Now, if you're sitting 3 tables back from me and you have new Bluetooth low-energy earbuds, you'll actually hear it through the Bluetooth link before you hear my voice getting to you. We're that good on the latency. And we want bidirectionality, so if I'm listening to music, I can also issue voice commands or talk to a voice assistant at the same time. We've totally separated the audio and the control, so you can mix and match and do sort of quite interesting things with that. We have true broadcast, so everybody in this room can listen to me. If it's up in the ceiling, you get about a 50 to 100 meter range with broadcast for Bluetooth because you're not having acknowledgements coming back. Now, that's really good. You can cover this whole hall with one transmitter. It's equally very bad because if you're in the other conference room, they're going to be doing the same thing. So we've got selectivity in there that allows you to have multiple different broadcasts. And you can use your phone or one of these or press a button on your trousers, whatever, to help you decide what you want to listen to. You can encrypt it for very interesting private conversations. And by very interesting, I mean sort of very interesting applications and user experiences, not just you're saying something interesting to somebody else. This basically shows you all the specs. I'm going to say little more than that, other than all the ones in blue are finished, they're adopted, you can go and get them. The ones in grey are probably no more than a month or so away, and there's already draft versions you can go and get. So lots of specs out there. If you're taking photos, I'm hoping all these slides will be distributed anyway, but take photos anyway. We have a new codec. It's called the LC3. It was developed by Fraunhofer. Now, it's, we think, about the most efficient voice and audio codec that's been developed so far. We've got sample rates go up to 48 kilohertz, but even at a 32 kilohertz sampling, this is better than any other codec we know. You can't tell the difference, or at least in all of the listening tests we've done with skilled and independent listeners, once you're above 32 kilohertz, you can't hear the difference from the original. And the great thing about that is it means you don't need as much airtime, so you can do more retransmissions, you can transmit multiple language strings at the same time if you want to. You've got room to actually play around and do other stuff with your design. There's some listening samples on the Bluetooth website. You can go and listen to those and make up your own opinion as to whether you can tell the difference or whether you have bat genes and it's not good enough. The one techie slide I'm putting in is basically showing you one of the things we're doing and how to make it work. You can separate each audio channel that you want into different pipes. You can send them to different devices. We have the ability that stuff comes in, you encode it, you then serialize it because you're going to send it over with retransmissions. But when you get it back again at the other end, we can synchronize that back to within 20 microseconds of left and right and as many other channels as you want. And that is synchronization to microsecond level, not millisecond level. And that means you don't get any feeling that the sound is actually moving round, which is what happens if you get a delay between left and right here. So lots of clever stuff in that. We've got some top profiles. We have some hearing access ones. It should be called hearing aid, but hearing aid is actually a regulated medical term in some countries, so we couldn't do that. And they let you do all of these things. You can do bidirectional voice. You can transmit to multiple people. You can pick up. So from my microphone, I could go directly to all of your hearing aids if it's a class of people with hearing loss. Lots of different topologies to play with. And as I said, control's important. You can put control into anything you want, and that can be controlling the volume of your earbuds, of the music you hear. It can equally be controlling whether you accept a phone call, or you want to initiate a dial, or you want to change your music track. And that can be from another button on anything you want. You can have as many of them as you want associated with your product. So lots of flexibility, particularly when we come into looking at how do you combine voice into smart home and other devices. If you're using the broadcast, you can use it for clever things like if you've got your own TV and you're naturally paired with it. If your friends come round, you can just say, come and join. Now, you could be publicly broadcasting to everyone, but then your neighbours can hear that you're watching sort of Fox News or some other channel that you don't want them to. So you've got lots of levels of encryption you can put in and then conditional access for people. And you can equally put it all in the cloud. So if you want to link this into cinema tickets so you automatically hear the right stream when you go to the cinema, you can do all of that. You can use that to make it a personal conversation with somebody when you're going up to a supermarket till, just by doing things like tap your phone onto a little pad, and that will automatically pick up the right channel and start a private conversation for you. Lots of new and interesting applications that you can't do today. Where we are, the basic technology to do this came out in the 5.2 version of Bluetooth a couple of years back. If your phone or product has a 5.2 chip in, it should be upgradable. There are at least 2 virtually complete open source stacks out there. One of those is going into the Android repository. Android already has support for most of this in the latest release. And we've got to the point, most of the specs are out. We think we'll see the first products coming out early next year. From what I've seen, we've got one company at least saying they're going to have a compatible phone out for Mobile World Congress in March. We expect earbuds at the same time, and then probably more of the branded products coming out next year. So the quick one is it's basically all there. It's ready to go. It's up for you. Quick plug, I've just finished writing a book on this. I'm hoping it'll be published so anybody who's sad enough can actually buy themselves one as a Christmas present. But yeah, that's it. Questions? Thank you.
Hello. So Bluetooth is already kind of a busy wireless technology since I think 2 years ago. Now you have angle of arrival, angle of departure, Apple's Find Me tags, and now Bluetooth audio. Isn't this a concern regarding interference and issues like this?
There's a yes and a no to that. There has always been a concern on every wireless technology that if you're running in the ISM bands, you have a limited spectrum that's available. Airtime is a real issue. We think we've done things to help with that. We have adaptive frequency hopping within Bluetooth already. We have an improved frequency hopping algorithm. The LC3 means that our packet size is about a third of what it was, so we've got smaller packets which are more resistant to interference. We're seeing moves of Wi-Fi as people gradually moving up to the 5 gig, which is actually resulting in a little bit more space down in the 2.4 gig. But other than that, yes. Oh, we've also added in power handling and power control into 5.2, so that if you've got your own devices together, you will start to ramp the power down. The biggest thing that we can do to actually improve it is persuade people to put their phones in a front pocket rather than their rear trouser pocket. Going from your rear trouser pocket up to the ear on your other side can give you 100 dB link loss, which means that both of them start ramping their power up. If you all held your phones in front of you, you'd really save the battery life of your earbuds. So, yeah, there's physics and the real world out there, but we don't think there should be a problem in most circumstances.
Makes sense. Thanks.
There are a lot of conversation at the moment about high-res audio, and obviously a lot of people are saying that it's impossible to really use wireless technology such as Bluetooth for that, and that you need to use a cable to enjoy your high-res. So why are views of Bluetooth in the future maybe supporting certain high-res technologies for audio in next maybe 3 to 5 years?
I spent an awful lot of my life having this conversation. The audio industry has got itself sort of set on a treadmill where it believes that nobody will buy anything unless it's actually got a lossless codec in it. They seem to forget that there are 2 events which really have changed the whole of music distribution over the last 20, 30 years. One was the introduction of the CD, which reduced audio quality, but made it easier to use. And the other was the introduction of streaming, which again reduced audio quality, and everybody loved it. What I think we're going to see is there are lots of interesting applications you can do with Bluetooth Low Energy. One of them is audio sharing. So if I come up with my phone and I'm listening to something and you come up and say, what are you listening to? I can just say, well, look, tap my phone and you can hear it as well. And then someone else comes along and says, but I've got something I'm sure is much better. Look, you just both tap my phone and then you can hear it. We can do that. Now, we can do that with 48 kilohertz, really high quality. What's going to then happen doing that? Because we've got longer packets, we need to put more retransmissions in, so you'll have a longer latency. And you won't be able to hear the difference. In a room like this, with this background noise, I can be transmitting at 24 kilohertz music, and nobody is going to notice that there's anything wrong with it. And what I suspect will happen is we will have some companies that latch on to the new applications they can do, push those out. At 32 kilohertz, you've got quite a lot of bandwidth. You can play lots of interesting tricks with your audio and do something that I think people are really going to enjoy. Or you can put it up, you can push it up to 48. Fraunhofer have a 96 kilohertz version there, which is meant to be as good at, if not better than, lossless. And I don't understand that sentence, but some in the audio industry do seem to understand that you can do better than lossless. I think users are going to vote with their feet in the way they did when CDs came out and when audio streaming came out, and just say, I like this experience. We have limited airtime. You can use it in different ways, and you can either stay on your treadmill and use up more and more of it to do the same thing that nobody can notice. Because to be honest, in here, everybody in this room has got a degree of hearing loss, which means they probably can't hear the top quality audio, even if they're sitting in a special room with the highest quality speakers. We like to think we can. It's why we buy gold-plated digital connectors, but we can't. So I think it's going to be really interesting to see how that industry evolves, because there are certainly product designers at major companies that just think the only thing we want to buy is basically based on the biggest number they can put on their box. And I think they're wrong. But I don't design these products, and I still tend to buy old things with cables for home. But
any other questions?
No, we have to give them exercise. Run.
I know, Nick, you've been always very good at seeing the future and seeing applications that most people haven't seen. Do you think there's something waiting to come and hit us from completely left field as a completely new application?
I do, and I think it's around these audio sharing ones. The other thing that's interesting is, if I go back to the hearing aid world, there's a lot of legislation going in to say you need to put hearing assistance in, and particularly in transport. So bus stops will basically tell you when the bus is coming. And today that's all based around telecoil, but it's going to be very easy to put a Bluetooth transmitter in to do that. And we have all of the metadata in those transmissions that your phone can pick it up. And if you're running a travel app, it will, you can be playing your normal music, and then you basically use this as audio augmentation. So it'll just suddenly sort of whisper in your ear, your next bus is coming. Or if you're walking down the road just with a normal one saying, now turn left here. We have that ability to now have lots of little audio beacons that can tell us real-time relative information based on our location. And I think that's an interesting one for apps developers, to just have this little guide whispering in your ear, whether it's about when your bus is coming or which platform your train is on, or if you're walking around a museum or somewhere else, just saying, well, I know what you want. I know from your applications what your preferences are. I've detected this. I'm going to mix it in with your sat-nav and your music information. And it's going to be, if that works, I think for most people, their first real experience of augmented reality. And it's no new tech. It's just their existing earbuds, but all of a sudden they get a different piece of information that they've never had before. And I think that could be compelling if it's done well. And that's another one where I think that the consumer audio electronics manufacturers are really blinkered. They just have a single vision of what they can do, and they don't understand the way they can actually get people more interested in the content.
Thank you very much, Nick. If there's no more questions, we'll move on to our next speaker. But thank you so much for that excellent presentation. Thank you.
Thank you.